Hello everyone. Myself Vishnu Sai. Today we are gonna discuss about the project predictive model for classifying the student grade. Um, our teammates are Nishanitya, Samya, Bindu. Uh, so let me get into the topic. Introduction for this topic is educational data mining (EDM). It highlights how EDM helps in the early intervention and enables the personalized learning for students by analyzing their academic data. The main aim is to predict the final grades using various input features like attendance, assignment scores, test scores, etc. Model efficiency, emphasizing the importance of the selecting efficient and accurate machine learning model. So, problem statement for this topic is educational data mining (EDM). It helps highlighting how EDM helps in the every intervention and enables personalized learning for students by analyzing their academic data. The main aim is to predict final grades using various input features like attendance, test score, and assignment scores. Model efficiency, emphasizing the importance of selecting a right feature for the building an efficient and accurate machine learning model. Means we have to select an accurate machine learning model which correctly predicts the student's performance. So, uh, project objectives is develop a predictive model, create a machine learning model that can classify students' final grade, evaluate multiple models, test and compare the performance of different machine learning algorithms to determine the most effective one. Feature impact analysis, understand which input like attendance, assignment scores most affect the grade predictions, and this improve the model accuracy. So continued by Bindu.
Methodology steps followed by the data generations. Data generations are the two synthetic students record is it will stored in the 200 synthetic student records, and second one is data processing. In the data processing, label encoding and the time test splitting. In the model training, decision tree, logistic regression, and the random forest. In the model evolutions, accuracy, precision, methodical, and F1 scores. In the future selections, in the correlations matrix and the recursive futures elimination in the data generate in that future selections. Model used the decision tree classifier. Accuracy for the accuracy 90%, logistic regression for accuracy 100%, random forest classifier accuracy 95%. Next, continue by Neshanitya.
Let me explain the code part. In this project, we stimulated data type for 200 students using features like attendance, assignment scores, and test scores to predict their final grades. A weight formula was applied to compute a final score based on their grades, like A to F. We assigned there. Then these grades are the encoded numerically using labeled data encoders to model training. A correlation matrix was plotted to analyze relationships between features and the triggered values. So, revealing the test score had a highest influence here. See, we can see here. And we predict the data by splitting into training and testing data and trained three machine learning models, that is logistic regression and decision tree and random forest. Each model was evaluated using a matrix like accuracy, precision, recalls, and F1 score. So with the random forest performance the best overall, we also applied RFE, that is recursive feature elimination, to identify the most important features, simplify the model without compromising compromising. Next, when it comes to performance, lastly, we visualize the distribution of grades, which I highlighting the most students received of A, B, and A, providing insights into overall classes and performance. The end-to-end pipeline demonstrate how machine learning can efficiently used to analyze the predict and outcomes. So when it comes to output, no. So here is the correlation matrix of output. This shows the linear relationship between features and the encoded final grades. Here the key values are test versus final grade encoded, that is 0 which is strong negative correlation, and assignments versus final grade encoded, that is here we can see 0.45 moderate negative correlation, and attendance versus final grade encoded, which is minus 0.23, that is weak negative correlation, right? Why we got negative here means we just given a label encoders like a is equals to 0, b is equals to 1, c is equals to 2. So we, what happened, so we get negative values. And when it comes to model performance, when it comes to model performance, right? Here we can see logistic regression, decision tree, and random forest. As I said, we used three models, and here are the three outputs. By this, we can conclude that logistic regression performed the best likely due to simplicity and linear of the data. Uh, and next, random forest performed better than decision tree as expected. All the models performed decently well, but logistic regression was almost perfect here. And when it comes to final decision graph, this bar chart shows the how many students got each grade. Like grade A students are up to 20 students, grade B 70 students, grade C 80 students, and grade D 25 students. And grade F, we don't have any students with grade F, so it is not showing here. Likely no one. Like most of the students are clustered around B and C grades. We can see here. The distribution is bit imbalanced, so this can be affect our model learning. You can want to ensure more even distribution in real time scenario if you need it. And this gonna be the code part, and next will be continued by Samia.
Feature selection insights. We analyzed which student details matter most in predicting grades. Test scores had the strongest influence. Correlation was minus 0.79. Assignment scores had a moderate effect, minus 0.39. And the attendance had very little impact, that was minus 17. We used recursive feature elimination and found that test and assignment scores are the most important features, while attendance can be ignored for better accuracy. Next, we'll go for a conclusion. Machine learning model can accurately predict student performance. Logistic regression gave the best results. Test and assignment scores are the most crucial inputs. Attendance has a little effect on predictions. Using the right features improve both model accuracy and understanding. So, thank you.
Thank you.
Thank you.